to solve quadratic equations if they're nice, pretty squares that you can just take the square root of both sides. We know how to do it if you've got three terms, so you've got to factor it. But what if it's a trinomial that's not factorable? There's got to be other options. So the next two lessons, the last two lessons of this unit, are going to be showing you how to solve a quadratic if it's not a factorable trinomial. So the first method is for me to do, so let's get started. The next method we're going to give you for solving quadratics is called completing the square. So our learning target is simply that I can solve quadratic equations by completing the square. And we're going to go ahead and define that before I start talking about your notes. Okay, so go to your glossary real quick. Completing the square is the process of converting a quadratic equation into a perfect square trinomial. So think back to the lesson where we talked about what perfect square trinomials were and how we factored them. And we do this by adding or subtracting terms on both sides. So pause for a second, get that copied into your glossary, and then we'll jump into some notes. Every quadratic equation that we've solved has either had just a single x squared that we can isolate and take the square root of, or it's been factorable so that we could find those factors and set them equal to 0. But there are lots of quadratic equations that contain expressions that are not perfect squares, which means we can't isolate the x squared and take the square root. And they're also not factorable. Think back to our factoring lessons. There were times where you couldn't factor. So when you come across equations that fit that criteria, we have to have some other methods of solving. So we're going to give you two methods. The first is completing the square, and that's what I'm talking about today. The next method is using something called the quadratic formula, and that'll be lesson 10. So we're going to be looking at some algebraic properties to rewrite quadratic expressions as a perfect square. Basically, we're going to manipulate it so that it's a perfect square. So your steps for doing this are going to be to move the constant to the other side. Okay, I'm going to get these steps down first, and then I'll show you what I mean by that. So we're going to move the constant to the other side. Once we've done that, we're going to find a number that completes the square using this formula right here. Then we're going to add that number to both sides of your equation, because anything you do to one side, you got to do to the other. The next step is going to be to factor, and then we're going to take the square root of each side and solve for x. Okay, so let's go ahead and look at some examples about how to do that. So there's a couple more things that I want to go over before we actually get started talking about examples. One, I want you to remember that the standard form of a quadratic formula is ax squared plus bx plus c. So when we talk about that letter b, what we're actually meaning is the coefficient of that middle term, the coefficient of your x. So that's an important thing to know. The other thing is, this says move the constant to the other side. Basically what that means is you need to rearrange it so that you have ax squared plus bx, and then your c is on the other side of the equal sign. So you want both your terms that have the x in it to be together, and then your term that's just a number to be off by itself. So in this case, we're not really moving the constant. Instead, we're going to move this x term because we need it to be over here with the x squared. So that gives us x squared minus 6x equals 4. Now my first step is complete, and I'm ready to move on to finding the number that completes the square. So the formula says b over 2, and I'm squaring it. In this problem, that b value is -6. So I'm going to go off and do a bit of scratch work and say if my formula is b over 2 squared, then I need -6 over 2 squared. Well, -6 over 2 is -3, and -3 squared is 9. So what I'm going to write in my equation now, the next step says that I'm going to add that number to both sides. So I'm adding 9 to both sides. What it's going to be is x squared minus 6x plus, and I'm going to add that number right here, equals 4 plus, and I'm going to add that number. So I'm putting that 9 right there. Okay, what that has done is now when I kind of simplify and write this a little bit neater, I've got x squared minus 6x plus 9 equals, and then 4 plus 9 is 13. Just focusing on this trinomial here, this is now a perfect square trinomial, where 9 can either be achieved by saying 3 times 3 or negative 3 times negative 3. And negative 3 times negative 3, if you add negative 3 plus negative 3, you get negative 6, which means this is a perfect square trinomial where my two factors are x minus 3 times x minus 3. The other side is still equal to 13. If you're having trouble remembering that, go back and rewatch that perfect square trinomial lesson because it's going to be really important for completing the square. So I'm going to rewrite this as x minus 3 squared. And now I'm able to do step 5, which is take the square root of each side. Because when I take the square root, I'm left with just x minus 3 equals plus or minus the square root of 13. And now my last step is just to solve. So I'm going to rewrite this right here. If I have x minus 3 equals plus or minus root 13 and I'm trying to solve for x, then I'm going to add 3 to both sides. So I get x equals 3 plus or minus the square root of 13. And that is my answer. All right, so let's do a few more examples that have some slightly different elements to them. For this one, this is written in your standard form right from the get-go. So it's already got the ax squared plus bx plus c kind of format going on. So I'm going to start by moving the constant to the other side. So that means I need to add 1 to both sides, which gives me x squared minus 2x equals 1. Now I need to find the number that completes that square, which means I need to find what number I'm going to add to both sides in order to make this a perfect square trinomial. And here's where I switch over to do my scratch work. And remember, it is going to be that middle number, that negative 2, cut in half and squared. So negative 2 over 2 squared. Following that order of operations, negative 2 over 2 should be done first, so that gives me negative 1. And negative 1 squared is 1. So I am adding 1 to both sides of my equation. That gives me x squared minus 2x plus 1, and over here 1 plus 1 is 2. So again, I'm going to focus right here. I know it's going to be a perfect square trinomial because that's what completing the square does. It turns everything into a perfect square trinomial. So thinking about the square root of 1, it's going to be either 1 or negative 1. It's got to be negative 1 since I've got a negative here. So my factored form is x minus 1 squared. We gave you a little hint here that factored form is always going to be x plus b over 2. So when we just did the b over 2 part, we got negative 1. That's what I ended up putting here, and that's going to work that way every single time. On the other side of my equal sign, I've got that 2. So my next step is to take the square root of each side. So taking the square root, that leaves me with x minus 1 equals plus or minus root 2. And now I'm ready to add 1 to both sides. So my answer is x equals 1 plus or minus root 2. Okay, you'll notice that both the examples we've done so far have had my a value equal to 1. That's because that's the way completing the square works best. If you don't have a equal to 1, we really need to try and find another way to do this problem. So here, the first thing I'm going to check is there a GCF? Can I factor out a greatest common factor? And in this one, each term here is divisible by 4. So I can factor out that 4, and this will leave me with x squared. 32 divided by 4 is 8x, and 16 divided by 4 is 4. So I'm left with this new equation. Now if I divide by that GCF, if I divide by 4, that's going to cancel and leave me with x squared plus 8x plus 4 equals 0, because 0 divided by 4 is 0. Now I can go about completing the square. So my first step is to move the constant to the other side. So I'm going to subtract 4 so that I have x squared plus 8x equals negative 4. And now I'm going to find the number that completes the square. So again, I want to put my little boxes there so that I don't forget to add it to both sides, because that is the #1 pitfall of people trying to do completing the square. And then I'm going to go off to the side for my scratch work. I want b over 2 squared. Oh, sorry. I don't know why I was about to write it again. So my b in this case is a nice, easy, positive 8. So I'm going to put 8 over 2 squared. 8 over 2 is 4, and 4 squared is 16. So that means I am adding 16 to both sides of this equation. That gives me x squared plus 8x plus 16 equals negative 4 plus 16 is 12. Okay, remember each time it is going to end up being a perfect square trinomial. Just going to give myself a little bit more space here. It is going to end up being a perfect square trinomial, so make sure that you're paying attention when you do your b over 2. That's going to be the number that is your perfect square. So it's going to be x plus 4, because my b over 2 ended up being 4, squared equals 12. Now I'm ready to take the square root. And when I take the square root of this, what I'm left with is x plus 4 is equal to plus or minus the square root of 12. Sorry about that, guys. Okay, so I'm left with x plus 4 is equal to plus or minus the square root of 12. Now, the square root of 12 does simplify, so you might want to do that first. I'm going to come up here and rewrite that. When 12 simplifies, you have a 3 and a 4, and the square root of 4 is 2. So that means that simplifies to plus or minus 2 root 3. And now I can subtract 4 from both sides. So what I get is x equals negative 4 plus or minus 2 times the square root of 3. And that's my answer. Okay, one more example I'll do for you guys, and then you can get to the practice if you haven't already turned me off. So here I'm going to start by moving that constant, just like we do every time. That leaves me x squared plus 4x equals 4. Now I am going to find what number completes the square using my formula. b this time is 4, and 4 over 2 is 2, and 2 squared is 4. Take note of that 2 there, because that's going to be what our perfect square ends up being in a second. So we've got x squared plus 4x plus my box equals 4 plus the box. And what I'm adding this time is 4. So going to both sides of my equation, I'm going to add 4 and 4. So that means I have x squared plus 4x plus 4 equals 8. And now my perfect square trinomial is going to be x plus 2 squared equals 8. I'm ready to take the square root. Square root of this side gives me just x plus 2. The square root of this side gives me plus or minus. Simplify this and you get 4 and 2. And the square root of 4 is 2, so it simplifies to 2 root 2. And now I'm ready to subtract 2 from both sides. That is a lot of 2's in one answer. I get negative 2 plus or minus 2 root 2. And I'm finished. Okay, guys, there is an application for this lesson, so make sure you do that before you start the mastery check. I promise you it's going to make the mastery check and the test a whole lot easier. So have fun. Let us know if you have any questions.